All right, so it's data science class year 2. The code is DSC2103. This time we're going to go through some data exploration, and you will see how everything ties into the tutorials you are doing on visualization and descriptive statistics, but there'll be a little bit of background from the mathematical side. So just to keep the communication going, please keep your microphones off and use the raise hand icon to ask a question. And I am inviting lots of questions, and this will be recorded. I will place the link on Moodle. As I noticed, Moodle cannot take very big files, so the video will then be linked to YouTube. Okay, so again, going through our learning objectives. For this session, I expect that we should be at learning objective 2, the practical analytical skills, and expecting that you should be able to identify any anomalies in your data once you have created the visual aspects of it and pinpointed what are outliers, what are the expected patterns. This was the course outline. I hope you all got it on Moodle, and the reference books that we are using. So you can use the two of them at the same time, because one's the statistical aspects and the other is the coding aspects. Okay, so regarding the group assignment 1 that you submitted, so because it was all submitted via email, it's a bit of a struggle to finish marking it or grading it. I will try to finish that by Monday and assign the marks. Please, for the next group assignment, which was supposed to be this week, but I will push that to next week. I'm expecting that all of us will have to submit via Moodle to make the grading easier. And then the individual assignments will come later on with the exam. The exam will be mostly practical with some bits of theory. Okay, so in the data exploration, this is when you get to see what patterns you can pick out within your data, how you can generate hypotheses or research questions about your data, and then continuously repeat the process of visualizing and again generating new questions. And so it is a cyclic process, and it continuously happens until you get to that point when you feel you are answering the questions that were stated in your hypotheses. So today we'll mainly focus on the exploration portion of that. So the first steps are that you will summarize and describe your data. And this is when we're looking at the descriptive statistics in the last 2 scripts that you worked with. And then the visual bits using the R Graphics ggplot2 package. Then we are going to explore more aspects in central tendency and variability, and I will expound more on that. And then in the lectures tomorrow and tomorrow and after morning, I think it is, we'll go on with how we generate the standard scores and looking at normal distributions, but we'll have a bit of that today. Okay, so you had the data set MPG that was in R, and you generated plots. And the process was that you created some aesthetics, you know, how you can make the graphs, the plots really presentable with colors and shapes, so that you can have your observations clearly stand out and those patterns displayed. Then you did some faceting, in which you could split the plots as you see down here to view different subsets of the data. And then you did geometric objects. In geometric objects, you could decide whether you wanted to create a line plot, a box plot, and so on and so forth. So these are the very same procedures that we're going to be using in exploring the data because they're part of that cyclic pattern. So which graphs were suited to which particular data sets? Because remember, we said there are different types of data sets. There are those that are discrete, there are those that are categorical, there are those that are continuous. And I hope you guys read up and followed the last lecture. So with the bar plots, this type, they will show comparisons between different groups. So they are suited for categorical data, and it is best that you have more than 2 categories of data. So if you look at that file MPG that had the different types of cars, the different types of cars would represent the different categories from compact to van. And so that's it's a form of categorizing what those different car brands or makes are, which is different from a histogram, because that will show continuous data that has an infinite set of observations. And it can also be suited for dealing with discrete data that may have a finite set of observations. The thing about that's different between the histogram and density plot, in as much as they're quite similar, is that the density plot will tend to show the volume of the weights of your observations. And it was in the book that I expected you guys to read. The scatter plot, which you guys played around with in the first visualization scripts, is that they will show relationships between 2 variables. So you can show relationships between a continuous variable, a discrete variable, or even a categorical variable. And you had the aspect of smoothing out some of these scatter plots so that you could have trend lines within them. And that is when you can have a line chart. There are more types of charts and graphs that you can look at if you'd use this link, because it's not exhaustive, but these are the major ones that you would find displayed for the types of data that we are looking at. So after you have displayed your data and you've seen what the pattern looks like, what the trend looks like in terms of the graphs, you want to then transform the data. And this was the script that I shared with you online. And we worked with the data set New York flights, when they were showing different flight departure times, what got delayed, what moved to which destination. And the first thing you want to do with before you transform your data is describe your variables. If you're in R and you write in the code !, New York flights, it should give you the structure of that actual data file. And you should then see for each of the variables, which are in columns over here, year, month, day, departure time, and so on, you should see whether something is an integer, which is represented by int, whether it's a character, and so on. So we'll see this even with the different data types that we are working with. Then you had to, because some of the data files were big, you then pick the particular observations that you want to deal with to answer the particular questions. And that you do by using the function filter. And there was also the option to reorder your variables or your rows using arrange. And you could even pick particular variables. Like you had questions within that script that I'm expecting to see tomorrow, where they were asking you which flights make which destination. So you could use the select, or you could use the filter option to figure that out. Then there was the option to add new variables to already existing variables. So essentially, if you have like a CSV file in Excel, but you wanted to do different calculations, like maybe tally up a mean or tally up a mode, you could add different columns of variables that you have named that with those calculations happening using the mutate function. And you could also collapse all of these values or your observations to using the summarize. And this is all in the transformation script that I shared. So once you have transformed the data, it doesn't necessarily mean that's the end of the situation. There is then the aspect of what we call the research cycle, which is then you generate questions about your data. Okay, so you go from visualizing it to generating models to transforming it. In the generating models is where you're asking questions that will help you, which you will then answer using particular aspects like your descriptive stats or your dispersion aspects, so looking at aspects of variation. So it's important how you go through the process of generating those questions, and how you search for those answers is the visualization, transforming, and modeling. But when you get those answers to those particular questions, you can refine the data because there will be things that jump out that show patterns that are unexpected or patterns that are expected, and you want to know why. So you have to then generate new questions, and those new questions we'll see as we go along the lines will come in the form of whether your data is skewed or whether you have outliers within your data set. But there is no set rule within the questions you ask, okay? However, two types of questions will always guide you. And these questions are always revolved around the type of variation that occurs within a variable, okay? And then the type of covariation that happens between variables. So essentially, if you have the two variables like car make and fuel usage, are those variables having the same pattern of variation as time goes on, okay, or as the mileage is increased? So those are the two types of questions you begin with, and then you go through your cyclic pattern using those questions, and then you point out what is standing out, what is an outlier, and you generate new questions. Okay. In generating the questions, those two that we have talked about, you first look at your summary statistics, and those you look at by generating your central tendencies, which summarizes your data because it goes to the center point of the data. If, say, you had a set of marks that are generated or grades generated within the class, you'd want to describe what the mean the class average is, or what the mode is, or the median is. And those help you understand, as we will see later, whether your data is skewed one way or the other, or if it has a binomial dispersion, or if it is appropriate, if you had selected your samples appropriately. Then you'll also look at the measures of variability. So that will show you how your data is spread. So these measures can be described by things like range, variance. We will later go on very in-depth into aspects of ANOVA and AMOVA, which are very key in data science, and standard deviations, and which standard deviation values do we stick to. So variance is very key in statistics, and you will notice even when you're practicing as a data scientist and anybody gives you their data to deal with, that is something you're going to have to work with. And covariation is very key because it shows you how two or more variables are related. So that also brings in the aspect of correlation, which we will later expand on. And the best way to visualize all of these things, or to discover whether there is variance, covariation, whether there is some skewedness in your data in terms of the mean and the median, is by creating the graphs to visualize. Okay. Just going into how variation is measured from the statistical aspect, before we go into using it in R, is that variance is the average of square deviations. So here in this table, we have heights collected from 5 individuals, ranging from 50 to 45. And to find, you first find the descriptive statistic, the mean of all these heights, which in this case was calculated as 48. You then subtract the mean from each individual height. Okay, that gives you the deviation. In some cases, you can see the deviation is positive, and in some cases, it is negative. Then you generate the square deviation of this. Once you have generated this square deviation, you then use that to calculate the variance, and this is the formula that is used to calculate the variance. In which case, this first x is the deviation, and the next x is the square deviation, and the total number n is, in this case, you have 5 heights that were recorded. So this value in total comes to a 6.8, but this is how R also calculates this kind of aspect, and it's always important to keep that in mind even when you're running the code. So when you're describing the data, like we're talking about the central tendencies within your data, prior to even calculating your variations, your ANOVAs, your MOVAs, you want to see if your data is normally distributed. Because for any tests to be calculated, or any hypothesis to be tested on your data, there is an assumption that your data follows a normal distribution. And in which case, when it follows a normal distribution, you'll have the case whereby, your data creates what is a bell curve. If you see over here in this graph, and over here in the middle, essentially being that your mean, your median, and mode are equal to each other. But you have to assess prior to running your ANOVAs, just so you can call out those biases or data biases or outliers and so, whether your data is skewed. And you'd explain that skewedness based on whether your sampling was good, whether you skewed it by sampling some group more than the other, or whether your actual assessments, your analyses were correct. And the skewedness can be either positive or negative. I will go more into that. And there's also a p-value that asserts a statistical significance to that skewedness. So if the p-value is greater than 0.05, you can conclude that the data doesn't deviate from normal distribution. But if it is less than 0.05 or 5%, then it's deviating from the normal distribution. Going on with the positive skewedness within a data is, and it's when you see your graph patterns. I'm sure when you guys were generating different graphs and charts, you must have seen some patterns in where your data mostly lies, whether it was going to the left or the right. And in the right skewed or positive skewed data is that it skews this way to the right-hand side. So, which is also seen here if you're trying to generate the curve. And this can also be displayed not just in a histogram, but in a box plot. You also generated box plots. And what happens with a box plot is that you will have a short tail, okay? My cursor is showing, hold on. So you'll have a short tail at the bottom and a longer tail at the top. And that shows that it's skewed to the right. So as opposed to having the bell curve, and if it was on a box plot and it's normally distributed, then these tails would be equally distributed. It would be right in the middle. So this also implies that your mean is greater than your median, and that the mean is overestimating the most common observations and positively skewing that distribution. So that highlights or pinpoints to you that there might be some outliers, or that this might be a new pattern that you need to investigate further. Then in the left skewed or negative skewed, the opposite is what happens, as you can see in these graphs. So I will allow you guys to ask me some questions. I'll just put my microphone off. Should I try and go on with this? Okay, somebody has a question? Does anybody have a question? All right, I will then, okay, there's a question. Yes, so.
Excuse me.
Yes.
I just needed a little bit of, I need more of an explanation on skewness.
Okay. Which aspects? The whole thing?
More about how maybe we can say plot it skewed to the right or to the left, like how exactly do I know, and maybe where is it applied, probably.
Okay. So when you get your data, like the data I've been sharing with you guys, the coffee data, for instance, the first thing you do is you want to explore it, okay? It's in an Excel format, it's in a CSV format. You're just seeing values there of the different variables. You have no idea how they will display, whether there's any correlation between the variables. So the first thing you would do is generate the graphs, okay? When you generate your graphs, you will see patterns. If you see it showing a round bell sort of structure, you will know that your data is normally distributed, and that when you're testing for your questions, you should have no issues or aspects of outliers. If they are there, they are probably things that are cropped up that are interesting forms of science for you to investigate. But if the graph then goes to the right-hand side, and when I say right-hand side, if you're looking at your screen, I don't mean the right-hand side where your hand is. You literally have to mirror turn it. So that if it's to the right-hand side, you know that is skewed in a manner that is showing you that there are possible issues with how you did your sampling, so that it means it's positively, yeah, skewing the distribution based on the fact that the mean that you're going to get, the average of all your observations, are going to be more estimated than your most common values. So they're giving you a sort of false positive mean. And then if it's in left skewed, it would be giving you the reverse. So where you would apply it is that it helps you understand how you should transform your data. And how you should transform your data will also inform how you restructure your questions that you're going to generate further on. I hope that answers.
Yes, it does. Thank you.
But let's look at an example. Does anybody else have a question? I will go ahead and first share the R script, which is on Moodle, by the way. I hope you've seen it. So if you recall, the first thing we started with was visualization, okay, the script visualization. And this was to help you practice all of that. But now we go completely into exploration bits so that we can see how we look at those very aspects that I had talked about. So did anybody download the script yet? Okay, right. So like I was saying, we go through the transform modeling cycle. And the first thing we want to do is generate the questions, and we go with the original standard questions. And then we search for the answers by visualizing. Once we've gotten answers that show us patterns that are unexpected, we transform the data and we model new questions that can help us refine how we answer or how we communicate the information that we have discerned from the data, because data science at the end of the day is getting information from data. So go through this script. And the libraries, you all know, are these. And we're using the dataset diamonds. So the dataset diamonds, if I could just show you, has information on particular diamonds that are being sold. There's over 50,000. If you could look down at this portion of the screen, we have the help section. It's showing 50,000 diamonds, and it's showing their price, their weight, that is termed as a carat, their cut, their color, their clarity, and other bits of information. But and that is the one we are looking at. So what we would first do when dealing with this data set is, it's a lot, 50,000. It's a lot of information. So we want to first see some patterns within it. And I'm not looking at all the variables. In this case, I am looking at one particular variable because the last time we were looking at mostly continuous variables. So this time we're looking at a categorical variable, which is called cut. So cut talks about whether the diamonds are fair, good, and so forth. And we are generating a bar plot. This was the same kind of script you used in the visualization. So if we generate that, okay. I don't know if you can see my screen properly. We get this bar plot that's showing us the count of each of this type of cut. Where the fair cut has way less and the ideal cut has way more diamonds, okay, in terms of count. So already this can tell us that in terms of the sampling, or in terms of the information that, say, this individual went out to get, there is already skewedness in how the information they've gotten. And this skewedness can't be helped because maybe that's what's really in the market. Maybe there are more ideal diamonds and there are fair diamonds. And the bars that we're seeing are showing us how much resistance. Yes.
So just knows everything about cloud.
Pardon? Somebody has a question? Okay, so you can see already how it's displayed that there's more of that, of one group of diamonds than the other. So you can also do this with any of the continuous variables. And here the continuous variable that I am looking at is the carat, which is the weight of the diamond. Okay, if I run that script, it's going to take a bit long. Does anybody have a question in the meantime? All right. We can see that the count is highest, right? For a weight that is between 0 and 1, okay? And it gets less and less as the weight is about 2 and beyond. So there's nothing beyond 3, okay? And this already tells us again that there could be some issues, or perhaps it's informing us that that's what's really on the market. Okay, so you can also display this in another format if you would like to. There are different types of graphs that this script talks about, but I will not go into all those details. We are also noticing that there are some interesting bits that down here at the 0, we can barely see some of these counts. Are they really there, or are they too small to be significant? We want to know how can we better observe these as whether it is they are outliers or they are issues, biases in the sampling. So, and we also want to know why is it that all the diamonds are less than 3 carats, or well, there are diamonds that are bigger than 3 carats, because our y-axis is still going all the way to 6. So we can generate a new data frame from the old one and use the filter function that you did with the transform script. And again, generate a histogram to see if there are any, if we can zoom in on this graph and see, and just focus on those diamonds that have carats that are less than 3, because our y-axis is going beyond 3, and we don't have really any observations beyond 3. So we can run that script. And it generates the new data frame, which is called smaller. And if we run it to observe it, plotted, we can now see that we have reduced the carat to less than 3. And now the display has completely changed. So remember when I was talking about, you can have the bell curves and you can have the skew to one side. You can completely see that there's some skewedness to the right-hand side, and again here, and again here, and again here. So this graph already tells us that there are subpopulations or subgroups, okay, within how the carats are counted, or how many groups of carats there are. And that now that is a pattern that you notice that helps you generate a question about your data. Okay. So you can also display this using the overlapping lines so that you can have a better picture if you want to, but I'm not going to go into that. You guys can go on with that. So now that you have noticed this pattern, you want to ask yourself questions like, what are the expected values in here? What is unusual about this data set? What could be outliers? And so you want to see what's most common and why it's most common, what's rare, and can you see any unusual patterns? Like in this case, we have seen an unusual pattern, and we want to know whether we can explain that pattern by generating an answer. Okay, so we noticed that the chart was raising those questions. Okay, and if we display it in this manner, so alternative ways of displaying it, which is to play around with the coordinates, the geoms, so that you can have more ability to zoom in on your data observations and see what it is you notice. Again, we are noticing these different groups that are formulating, okay? And they're all skewed to the right-hand side. So there's a positive skewedness, which is implying that the mean is greater than the most common observations. Okay, so when you're answering your questions or when you are generating information, say you're writing it for a scientific journal, say you're writing a report for whoever has given you their data, these are things you take note of and you write in that report with the displayed graphs. So I have posed some questions in here within the script for you. For instance, why are there more diamonds at whole carats and common fractions of carats? For instance, if we look at the carat 1, okay, we can see a lot, a big count, and then as it goes down into the fractions, it becomes less and less, say 1.1 and so on, 1.2 until it gets to 2, it gets less. Why is that? Okay. So how you will generate the response now depends on how you did your sampling and how, what you observed when you were going out there into the field and getting this information. One aspect I could give, because I didn't collect this data, is that I could assume in the market when diamonds are being sold, nobody sells diamonds saying to you it's a 1.1 something carat. They usually round off the numbers because that's how they sell them. So it's likely that the reporting is more to whole numbers than to fractionated numbers, which skews the data. So again, that's why there are more diamonds slightly to the right rather than the left. And why are there no diamonds bigger than 3 carats? Now, the bigger than 3 carats, I may assume that this is not something that's sold, but I could also further on go examine the data, explore the data from the aspect of comparing variables. I could compare the carat variable with the pricing. I could compare the carat, the pricing, and the size. And I see, is it that if it went over to 3 carats, the pricing could be too high and the market couldn't take it? So I'm generating a question there that could possibly give more information about the data if this was a market study. Okay. So I have some questions here for you guys to answer. And I really look forward to the presentations tomorrow on these questions and see how you guys are analyzing all of this and how you're critically thinking about the possible questions or the possible answers. Then we go into looking at outliers or unusual values within the data sets. So outliers would be unusual, they don't seem to fit within the graph, but doesn't necessarily mean that they don't need to fit there. Sometimes they don't fit there because there are errors, and sometimes they don't fit there because it's something new, it's something interesting that you need to explore some more. So it's up to one's discretion in how they analyze their data, as long as they can justify how they treated the outliers, whether they got rid of them or whether they kept them and continued working with them in the data set. So if we look at, say, the variable y, and if I could go back to what the variable y was in this data set, we could look over here. The variable y is the width of the diamond, and they're saying the range is from 0 to 58.9. Okay, if we generate a plot, a histogram plot, just showing that width, run that. Okay, we can see that it is completely skewed to the right-hand side. The y-axis is too long and going beyond any of the observation points. Okay, so it's pretty much stopping at around 10, and there's nothing, no observations beyond 260. But I'm not even sure if that's the way it is, because I can see some observations down here that are too small for me to observe. And this could also mean that maybe there's some skewedness to the data, but I just want to investigate and zoom in on these points and see what if there is any interesting pattern about them. Okay, so to zoom in, use the coordinates function, which you had also used in the last script for visualization. And I am just changing the bandwidth to, or the bin width to 0.5, so that it can just zoom in and I can be able to see those points a little easier. Okay. So what's interesting is a graph that was previously like this is now looking like this when I have zoomed in on it. Sorry, the screen's a bit small, but you can notice that we had these little points that we couldn't notice previously, and now we've zoomed in on them. There's a point at 10, or 0 rather, there's a point at 32, there's a point at 59. And these points seem a little unusual because it's not possible, they said the width should be up to 58.9. So it's not possible for the width to be a 0, because otherwise that's a non-existent diamond. So which means the way in which they were categorizing the variable y was incorrect by saying from 0. And then if we look at 59, this goes beyond the width that's expected for a diamond in that kind of market, if it's in the jewelry market. So they had set particular boundaries, and this can point out to us that we have outliers within our data. Okay, and we have zoomed in on these. So later we will talk about how we can filter out these outliers and what we can do with these outliers. But I just want to see how you guys manage to answer some of the questions within the script. There is some examples I put within the script about how to remove them and how to maybe filter them out, but it's not complete. I'm looking forward to Thursday when we can get to try it out together. I will be in the class in person. So do you have any questions? I will stop the recording now. So